We'd like to save all the questions for the discussion session at the end. Thank you. Our next speaker is Menno Smit, and he recently concluded a trial in Kenya. He's going to present his results from that trial.
Good morning, everyone. My name is Menno Smit. It's an honor for me to present this trial to all of you this morning. The title of the trial is The Efficacy and Safety of High-Dose Ivermectin for Reducing Malaria Transmission. And as Brian just showed us, ivermectin, when distributed at the community level, can have a potent effect on malaria transmission in the community. And the purpose of this trial was to see how far we could push this effect in terms of mosquitocidal duration of ivermectin, considering both efficacy and safety. So this study was conducted in Kisumu, Kenya, and is a collaboration of the Kenya Medical Research Institute, the U.S. Centers for Disease Control and Prevention, and the Liverpool School of Tropical Medicine, and was funded by the Malaria Eradication Scientific Alliance. So, like I was saying, the main objective of this trial was to determine the safety and efficacy of ivermectin at doses of 0, 300, 600 micrograms per kg per day for 3 days when provided with a standard 3-day course of dihydroartemisinin piperacin, or DP, for uncomplicated malaria on 14-day mosquito survival after a feeding experiment performed at visit 7. In other words, 7 days after the start of treatment. So just to be clear, because we're talking about both mosquito follow-up time and human follow-up time, we're going to mention all the human follow-up time in visit numbers and the mosquito follow-up time in days. But visits also stand for days. So this study was a double-blind, placebo-controlled trial, parallel group, 3-arm superiority trial in adult outpatients with uncomplicated falciparum malaria. It had a cluster randomized design. The patients were the clusters. We enrolled 141 participants, and the mosquitoes were the unit of analysis. And this was because we were administering the drugs to the humans, which were the clusters, and then following up the mosquitoes for their survival. At each feed, we fed approximately 150 mosquitoes, and our total sample size was 141 patients and 151 mosquitoes. The primary outcome for the trial was the 14-day survival of mosquitoes fed on patients at visit 7, or 7 days after the start of drug administration. And secondary outcomes included mosquito survival up until day 28, which was measured daily, after feeding experiments performed at visits 0, day 2 and 4 hours, the Cmax of ivermectin, visits 7, 10, 14, 21, and 28. Furthermore, we also looked at malaria clinical and parasitological treatment response by visit 28. We studied the pharmacokinetics of piperacin and ivermectin, which we won't present today. And we also looked at safety. So that means we measured pupil diameter in the patients at each and every visit using this device on the right, which is an automated pupilometer, which basically locks onto the pupil and measures the diameter during a period of 5 seconds. And then gives about 180 readouts. Then we also looked at QC interval prolongation using ECG, which we repeated in a total of 4 visits. We also determined hemoglobin levels at each visit, monitored SAEs and AEs during the entire duration of follow-up. So like I was mentioning, there's 2 timelines going on in this study. So first of all, we have human time, which we're expressing in visits, from visit 0 up until visit 28. The drugs were administered at visit 0, visit 1, and visit 2. And then we did further blood draws all the way out until visit 28. In terms of mosquito time in days, like I mentioned, our primary outcome was the 14-day survival of mosquitoes that were fed at visit 7. But we further followed these mosquitoes all the way out until day 28. And similarly, at each time point that we did blood draws, we fed this blood to the mosquitoes and also followed the survival of these other clusters of mosquitoes all the way out until day 28. So we did this before drug administration at baseline. We did this at visit 7 in 2 hours, which is the Cmax, and then continued to do that out until visit 28. So for this study, the main method that we used was membrane feeding. So we drew blood from the participants inserted this blood into these glass bells with artificial membranes, and then allowed the clusters of mosquitoes to feed on this blood for approximately 30 minutes. The mosquitoes that were fully engorged, we then kept and monitored up until day 28. And at each and every feed, we fed 3 cups of 50 mosquitoes. So we wanted to also, so we did this at the 7 different time points that we did blood draws from the participants. So in order to ensure that this kind of artificial membrane feeding method was truly depicting what would happen in a true natural setting where mosquitoes would feed off of the skin of a human being, we also asked participants whether they wanted to participate in direct skin feeding at visit 7, which was the same time point as our primary outcome. And 50% of participants provided additional consent to also do the direct feeding. So how did we get to our dosing regimen of 600 micrograms per kg per day? So like I said before, what we were trying to do in this study was to maximize the duration of mosquitocidal effect, or in other words, the time above the lethal concentration of ivermectin that it takes to kill 50% of mosquitoes that feed off of that blood meal. And at the same time, we wanted to stay within the established safety boundaries. In other words, we wanted the Cmax of our dosing regimen not to exceed the Cmax of a single dose of 800 micrograms per kg, which has been given to over 400 participants in different studies. And at the same time, we also wanted to develop a dosing regimen that was similar to that of DP, which is once a day for 3 days. So looking at this PK curve, which is a PK simulation, on the right side, in black you see the concentration of a single dose of 800 micrograms per kg. And this blue line across the bottom is the LC50. So basically, the concentration at which you're still killing 50% of mosquitoes that feed off of that blood. And you'll notice that with the single 800, it dives below the LC50 at approximately 1 day and 22 hours. So the regimen that we used was 600 micrograms per kg per day for 3 days, which is the green line. And you'll notice that here, the predicted fall below the LC50 is 6 days and 18 hours. So this is very important to remember. So around visit 7 is the latest time point that we're expecting ivermectin to still be killing mosquitoes. So now moving towards the results, just very briefly about baseline and follow-up. We can say that at baseline, the participant characteristics were well balanced between the arms. And during follow-up, there was also equal attendance at the primary outcome time point at visit 7. So the results. So at this point, we need to keep in mind what is our ideal duration of effect. Perhaps 8 years or longer would be ideal, but probably not what we can expect. So what is the duration of mosquitocidal effect after ingestion by the human? So this is our baseline feed, so before any of the participants had received ivermectin. This is a Kaplan-Meier curve, so across the x-axis, you see the survival time in days, and then across the y-axis, you see the cumulative death rate. So basically, the faster these lines shoot up, the better the ivermectin is working. And so between the different study arms, we see no difference at baseline. So now, moving on to our results. So this is actually quite surprising. So we see very clear mosquitocidal effect of ivermectin all the way out until visit 28, which is 4 times longer than we had initially expected based on what we know about the pharmacokinetics of ivermectin. And these differences are statistically significant. I'll spare you all the tables at this point. So we also looked at direct feeding versus membrane feeding, and we found that there's no difference between the mosquitocidal effect of ivermectin at visit 7 using these doses between direct feeding and membrane feeding, meaning that we expect that what we're seeing, the results we're seeing from membrane feeding truly depict the same thing that would happen if all of these mosquitoes had fed off the skin of humans. So we just looked at the duration of effect after ingestion by the human. Now we're going to look at the duration of mosquitocidal effect after ingestion by the mosquito. Or in other words, after the mosquito ingests that blood, how long does it take before that mosquito will die of that blood meal? So you might think immediately, or you might think there might be a slight delay. So let's have a look at that right now. So in both of our intervention arms, so the 300 and the 600 microgram groups, we've set out in these curves the daily hazard ratio for death at each and every visit, and then, the days post-feeding. Sorry, I keep pressing the wrong button. This one. So what you'll notice is that after a mosquito ingests ivermectin here at time point 0, initially in the first, say, 5 days, there's a very high hazard ratio. So that's when most of the mosquitoes are dying. But this effect actually continues until approximately day 12 after ingestion. So this is very important for future studies that these studies will have to follow mosquito survival for at least 12 days after exposure to ivermectin-laced blood meal. So in terms of our safety outcomes, because now we're seeing extremely high efficacy, but it's also very important to see if we're not having any adverse effects on the human subjects of this trial. So the first thing that we looked at was the QT-CF interval. So prolongation of the QT interval can lead to torsade de point and potentially be fatal. So this was a very important outcome to assess. And we conducted ECGs at visit 0, visit 2, at Cmax, visit 2 plus 4 hours, and then finally at visit 28. And we found no differences in terms of QT interval duration between any of our study arms. So this was very reassuring. So this is our main time point of interest. There's no differences there. Then the second safety outcome that we looked at was pupil diameter in millimeters, due to the fact that extremely high doses of ivermectin, when given to, for example, animals, one of the first side effects you can see is an increase in pupil diameter. So we measured this at each and every visit, and we did find a small difference, although probably not clinically relevant. At visit 7, the intervention arms, the pupil size was 0.2 millimeters larger than in the DP-only arm. And there you see the values. So these are different values. So the important thing is, so although we saw this difference at visit 7, we also looked across all visits and took the maximum pupil size that each and every human achieved and then compared these between study arms. And we found, because there might be a variation in the time point that each participant achieves maximal pupil size, and that's the thing that we're concerned about. So there was actually no significant difference between the study arms in terms of the maximal pupil size. And third and lastly, we also looked at hemoglobin concentrations at each and every visit. And here we saw also a small, probably clinically not relevant difference between study arms, in which it seemed that the nadirs were taking place at different time points. So for the DP-only arm, the nadir was around visit 7. For the 300 microgram arm, it was at visit 10, and for the 600 microgram arm, it was at visit 14. And if we looked at the nadirs across all study arms, again, we didn't find any difference in the values between the study arms. Finally, in terms of adverse events, so we also monitored AEs and SAEs during the duration of follow-up. We had 2 SAEs. One participant in the 300 microgram arm had ECG abnormalities a couple of hours after the final dose, which included an asymptomatic QT prolongation of 521 milliseconds with T-wave inversion. So although this is definitely an SAE, these types of adverse events are known to occur with DP, so the antimalarial drug that we were using in our trial. Remember the QTCF chart, so we didn't see any difference in terms of an interaction between ivermectin and DP, and therefore a potential increase in QTCF prolongation. The second SAE was in the 600 microgram arm. There was a patient who developed an anaphylactic reaction with generalized urticaria and severe abdominal cramping. In terms which are again also known side effects of each of these drugs. So at this point, we don't know if these side effects could be related to the DP or to the ivermectin. In terms of adverse events, so the number of participants that experienced at least one AE was slightly increased in the intervention arms. However, many of these AEs were not related to either of the study drugs in terms of the known side effects of these drugs that have been studied for several decades, and in terms of their time causality between drug administration and the time point that the AE occurred. Of the ones that were related, a large number of them were actually transient minor visual disturbances that have been previously described in previous studies with ivermectin given to onchocerciasis patients. So in summary, we can say that 600 micrograms per kg per day for 3 days has a mosquitocidal effect up to 28 days post-drug administration in humans, and has a mosquitocidal effect after imbibement by the mosquito that can take up to around 12 days. Secondly, membrane feeding and direct feeding show similar mosquitocidal efficacy, that ivermectin is well tolerated at doses of 300 and 600 microgram per kg per day for 3 days. There was no difference in terms of QTCF prolongation. There were mild, transient, of a few hours, visual disturbances reported by a small number of participants, similar to previous ivermectin studies in onchocerciasis patients. And previous studies found no effect on HB and pupil diameter. However, we found small differences at different time points. However, no differences in HB nadir or pupil maximum. However, it would be useful to reassess these further in larger studies. Our drug levels are still pending, so it would be very interesting to also look at the PK-PD relationship and try to further understand why the efficacy of ivermectin in killing mosquitoes is so much higher than we imagined. Potentially, there's some sort of novel mosquitocidal metabolite, or there's a drug interaction going on between ivermectin and DP. So in conclusion, we can say the primary analysis of the small dose finding study showed that oral ivermectin at doses of 300 and 600 micrograms per kg per day for 3 days was well tolerated and free from harm, and had a major effect on mosquito survival. High-dose ivermectin, therefore, is a promising novel tool to kill mosquitoes after drug administration to humans, and larger population-based studies are required to determine the impact on transmission and to provide further reassurance of its tolerance and safety at these higher doses. Prior to these studies, we recommend that similar dose-finding studies are needed in the younger age groups. Thank you very much.